So, Asterisk architecture. Asterisk architecture is actually one of my favorite things to talk about. And honestly, as we start to get here, like I said, into some of the technical content, if you really start to understand some of the architecture or some of the ways that Asterisk works on the inside, this is really what helps you with troubleshooting and deployment and understanding how it works. So we'll just talk about Asterisk in Linux and modules, channels, interfaces, and our config file syntax. Okay. So to start, Asterisk is going to run on any Unix-based platform, and we've got a few folks in the back, and there's several chairs up here in front. If you guys would like to come forward and grab a chair, we definitely have room for you guys. So Asterisk is going to run on any Unix-based platform. So this includes Linux, but also FreeBSD or even OS X runs Unix at its core. But the reality is Asterisk runs best on Linux. So it's developed on Linux and it runs best on Linux. Linux is an operating system. Just like Mac OS X, I mean really Linux is a kernel and then operating systems are built on the kernel. But to kind of abstract it for a moment, think of Linux like an operating system, just like you've got Mac OS X, you've got Windows, some variant of that. You've got Linux, and there are many variants of Linux. So kind of by analogy, if you guys remember back in the days, you kind of had Windows 98, and then you had Windows NT. And they were both Windows, but they were kind of different flavors of Windows, right? And I think, I don't keep up on the Windows world, but do they still have some, like does Windows 8 have like Windows 8 Home and Windows 8 Enterprise? Does anybody know? That's awesome. Nobody in the room knows about Microsoft. That's Microsoft doesn't know either, which is actually really cool. Like I said, I don't pay as much of attention, but in any case, the point is, you've kind of got different flavors, and so Linux works in the same way. You've got different flavors of Linux, and they're called distributions, okay? And so at the heart, at the core, there's a couple core distributions. So like Red Hat Enterprise Linux and Debian, and out of those core kind of distributions, and there's a few others, but they branch out and they're called forks, right? So Asterisk runs on Linux, and these are a couple different flavors. You've got Debian, and then based on Debian, Debian's kind of like the hardcore server, like Uber Geek distribution, and then more friendly, user edition is kind of Ubuntu. Ubuntu is based on Debian, and you've kind of got Red Hat, Fedora, and CentOS, or CentOS. And typically, a lot of people will ask me, well, hey, I'm new to Asterisk. I'm, maybe I came from the Windows world or I came from the Mac world, and I'm not as used to Linux. Which distribution should I use? And the answer I tend to tell people is, who is your friend that's like the Linux geek, right? So if you have a buddy and he just knows Linux and he typically has a really big beard, then whatever distribution that guy uses, that's what you want to use, because it's really about community and you want to have a connection, okay? So if you want to run it on Debian, run it on Debian. If you want to run it on Fedora, run it on Fedora. Asterisk will run great. Most of our developers at Digium use Debian, but the most popular software that Asterisk is built upon is actually CentOS. And so I'll talk just for a moment about the relationship between Red Hat, Fedora, and CentOS, okay? So Fedora is put out, it's kind of supported by the Red Hat company, right? And this is their open source software, so it's kind of freely distributed, and just like Asterisk, there are developers all over the world that contribute code to Fedora and put that code in. And so Fedora is kind of like the development branch. And we're going along and we're putting new features in and we're fixing bugs and we're doing cool stuff. And then what Red Hat does is they branch the code. And out of that branch, they package it up and they stick some logos on it and a few other things, and they make Red Hat Enterprise Linux, okay? And so you got Red Hat Enterprise Linux, and then the development of Fedora continues. And then when we've got a new version of Fedora and there's new cool stuff in that, then they take another branch, and then you have another kind of snapshot. Hey, now we've got Red Hat Enterprise Linux 6. So here's Red Hat Enterprise Linux 5. We have Red Hat Enterprise Linux 6. And so the concept here is Red Hat Enterprise Linux doesn't really have its own development branch, right? There's like this software is not really developed. It's developed in Fedora. And so if you want to know what's the future that's going to be coming in Red Hat Enterprise Linux, you can look to the Fedora project, and you can kind of see what's going on there. Those are the types of features and functionality that will be branched off by the Red Hat company and put into Red Hat Enterprise Linux. Cool thing about Red Hat Enterprise Linux is that you can purchase software, and you can get support on it, just like you can get support on Asterisk, right? Now, you have the Red Hat Enterprise Linux, and of course, that's a product that comes at a cost, and so you can purchase that license. And so there is also the Community Enterprise Linux, or Community Enterprise OS. And that is what CentOS is the Community Enterprise OS. So the CentOS community takes Red Hat and basically makes a clone of it, okay? And so when you're running CentOS, it's a clone of Red Hat, which is a fork off of Fedora. So that's kind of the relationship there. I would say if you don't have a good buddy who knows Linux really well, and you're new to the project, and you're just shot in the dark, throwing a dart at the dartboard, hey, I want to start learning about Linux, I recommend CentOS because it's a very popular distribution. Many people who are using Asterisk run it on CentOS, and that's kind of the relationship there. Coming back into Asterisk. Asterisk is modular in its design. And so what that means is Asterisk has a very simple core, and then it functions based on dynamically loaded modules, okay? What does this mean? So essentially, Asterisk has a core, and the core doesn't really do a whole lot. So this would be kind of like a picture here of our Asterisk server, and here's the core. So right now, we have Asterisk, and we have the core, but we don't have any modules loaded. And Asterisk isn't going to really do anything. It can't even make a phone call because there's no modules loaded. So what we've got here is over here are like the modules. And you know, they look like little dots. But in reality, these are Linux shared objects. They live in varlib asterisk modules. And when you build the software of Asterisk, you get to select which modules you want to build. And there's a really nice tool I'll talk about later on that shows you how to resolve your dependencies there. So imagine for a moment that this kind of orange dot here represents appdial.so. So that's a Linux shared object. It's a little piece of code. And that modular piece of code is the code that actually allows the dial application to dial out of Asterisk. So right now we just have the core. Asterisk can't even dial out. But if we load that module into Asterisk, right, now Asterisk can use the dial plan application. So dial is actually what we call the dial plan application. And with that module loaded, we actually can now use that functionality. So what's cool about this modular design is that if you need to add functionality to Asterisk, right, if you have some kind of custom implementation or you need Asterisk to interface with some type of other maybe proprietary solution within your own company, you don't have to dig into the core of Asterisk. You don't have to you know, muck around. You can actually create a binary module to add that extra functionality. So I'll give you an example. Today we have various channel drivers, and I'll talk about channels in a moment. But you know, we have channel drivers for SIP. If you want to connect a SIP phone, we have a SIP module that you load into Asterisk. It's called chansip.so. You load chansip.so, now you're talking SIP. Well, what if you want some other kind of protocol? Let's say you want to run Cisco's proprietary protocol. Let's say you want to run Skinny, which is SCCP, right? Well, how do we get SCCP into Asterisk? Well, we don't have to break apart the whole system. We just create a binary module that has a standard set of APIs, and that's actually been done by the community. So community folks have actually created an SCCP module. You can load the SCCP module into Asterisk, and hey, now all of a sudden Asterisk will talk SCCP. Now, the support for SCCP is obviously not going to be as good as the support for SIP. SIP is what we call a core module. The core developers, the guys who were hanging out in the DevCon yesterday, really focus on and support and bug fix those modules, as opposed to what we call community modules. Community modules are those built by those in the community, but they're also supported by those in the community. Obviously, as Cisco updates or changes things, none of us have any control over that, so something could change and it could break the module. That actually happened with Google recently. Google kind of changed the way that they interfaced, and so the modules that we were using to talk to Google broke, and there's nothing you can do about that, right? Actually, today, we used to use something called Chan Jingle. Now there is Chan Motif, which is a kind of new channel driver in Asterisk. It actually talks to a Google Voice trunk, and so that's really cool. If you want to connect a Google Voice trunk into Asterisk, you can do that, load a module, and hey, now you've got that functionality. So the reality is if some new protocol comes out, if some new thing comes out, we need to add that into Asterisk, we don't need to rebuild the whole project. We can load a module and get module architecture. Of course, there are many other ways to build, to extend Asterisk, to make it extensible. So we've got AGI and AMI, programmatic interfaces, ways to control Asterisk and integrate other solutions. And I'll talk about that as we go along, but at this point, we're talking about the modular architecture. So let me see if yeah, we have a question. Hey, that's an excellent question. Do we load the module at load time, or do we compile it? So let me see if I can actually. I'm gonna try something out here and see if I can do a bit of a live demo. We'll find out. Let's see here. Let's try this. Let's see. Okay. So let's see if I can bump this up a little bit. Okay. So can you guys see that? Let's get that just a little bit. Is it cut off a little bit there? That's probably good enough for us. Okay. So if we go to var lib asterisk modules, nope, user lib modules. Okay. So here are where the modules live. Okay. So the question was, are these loaded at runtime or they're compiled? Well, it's kind of both. So when I compile Asterisk, these are the modules that I compiled. So I obviously have a tool that I can choose which modules are compiled. And so I don't need to build all the modules. I can just build the ones I want, and they end up in this directory. So for example, resdigiumphone.so, that's the module that runs the DPMA. That is the DPMA, what we call the Digium phone module for Asterisk. And that allows our phones to be auto-configured, and it allows our phones to have some special functionality. For example, to pass voicemail to the phones, or to have status passed. It runs through that module. There's Chan SIP over here. This is the SIP module I was talking about. And so they live in this directory. What happens is when I start Asterisk, at that time, when Asterisk starts up, it's going to look into etc asterisk, which is the configuration directory, and it's going to look at modules.conf. So here in modules.conf, I have the ability to tell it, hey, auto load equals yes. And so what I would say is all of the modules, whatever you find in there, go ahead and just load them all. So at runtime, Asterisk boots, and it goes and it looks in varlib asterisk or user lib asterisk modules, loads in all of those modules. Hey, we're good to go. But you would say, well, I don't really want all of those modules. And in fact, if you want to tune Asterisk, and so if you're looking for optimization, obviously this is standard to any software. When you want to optimize, turn off the stuff that you don't want to use, right? One way that you do that is in modules.conf. And so in addition to auto load equals yes, what I want to do is I want to tell it to no load some specific modules. So you can see here the GTK console, I've specifically no loaded that module. And so I can specify the modules that I don't want to use. This is going to do two things. One, it's going to optimize my server, tune it, make it run a little bit faster. And secondly, it's going to make my server more secure, right? So for example, I talked earlier, you can run proprietary Cisco SCCP, and that can be running on your system. But if you're not using it, why would you want those ports open, right? If you're not using it, why would you want that vector of attack? Let's close that off. And you do that by no loading the Chan Skinny module, right? So this is a way to tune and secure your system. In addition to the load time, I can specifically load a module. So for example, if I do module unload chan sip.so, okay, I've now unloaded the SIP module. Okay, there is no SIP channel. In fact, if I try to make a phone call between my phones here, it's going to say, hey, you can't make a phone call because there's no SIP module to make a phone call, right? And you can see that this module contained several functions, dial plan functions, SIP peer, SIP chan info, or dial plan functions we'll talk about later today. Several applications, SIP add header, dial plan application, and some other parts of that module that were unregistered. So if I want to load that module back in, I can load the module, okay? Now that I've loaded that module in, and I've got some DNS errors because I'm running a weird kind of network here. But the idea is now that module is loaded, now I can make my phone call. And it's also read in the configuration. So in a moment, we'll look at the configuration files. But the configuration for SIP is built in sip.conf. And that's a text-based file, right? So when I edit the text-based file, Asterisk doesn't know that I've made those edits. I edited a text-based file, but now I need to tell Asterisk, hey, I made some changes. Read in that configuration. And the way that configuration is read in is when you reload the module. So there's a couple ways I could do it. I could say SIP reload, and now I've just reread in my text-based configuration. Or I could say module reload chan sip. I can specify specifically chan sip and read in that configuration. So that is kind of how you can load modules. You can do it from the CLI. You can also do it from a script. Or, like I said, at runtime, when it boots up, it's going to look at modules.conf and say, what do I do? I want to auto-load, and I want to specify some specific modules. So this is the core. Like I said, Asterisk has a pretty simple core. The core handles the module management. It handles the reading into the configuration, the system timing, channel management, and not much else, right? Very simple core. The power and the functionality of Asterisk are added in a modular fashion. Like I said, that's one of the ways that makes Asterisk easy to rapidly put in new features and to be able to add new components. So like I've just got some of the detail here. They're all going to be Linux shared objects, typically type and then file name. So if it's a channel driver, it's going to be like chan sip. If it's an application module, a dial plan application module, it's going to be like app dial or app voicemail. And this is kind of what I just showed you there. We can look at the modules. So channels within Asterisk. Okay. So the channels. I like to draw this picture, and we'll see if I can draw a picture here. So imagine a channel. It's not like a TV channel, right? So if I have a picture of, let's say, the UK, which is that's kind of terrible. I mean, I don't know, that looks like a party hat. Maybe if I put like a little puffy ball here, and maybe like some trim. So don't tell David Duffett that I don't know how to draw England, because he'll be mad at me. In any case, if this is the UK, and then here's like the mainland here, right? We've got the Baltic Sea and the Black Sea, and what do we have between them? It's the English Channel, right? So if you think of the English Channel, that channel connects two bodies of water, in this case the Black Sea and Baltic Sea, but the channel is what connects two things together. Well, it's the same thing in Asterisk. We have a SIP channel that's going to connect SIP calls in. We've got an EEX channel. It's going to connect EEX calls, right? DOTI channel. DOTI stands for the Digium Asterisk Hardware Device Interface. DOTI channels are going to be like TDM channels that coming off of your PRI or an analog channel coming off of a card, right? So maybe I can put another picture in here. Imagine you've got over here, this is your Asterisk PBX, right? And I want to make a call to a phone, okay? It's going to have a channel into Asterisk, okay? And here's another phone, right? So let's say this channel is SIP, and let's say this channel, of course the bidirectional channels, is going to be DOTI. Okay, so this is how Asterisk can translate between two technologies. It's got a SIP call that comes in, it sends an analog call out. Asterisk will do that just fine. So the question is how many channels do I have open right now? I've got 2 channels, right? I've got channel in from one phone, going to Asterisk, channel going into DOTI, 2 channels, right? What if I've got another phone over here, okay? And let's say this is also a SIP phone. Okay? If I make a call from this SIP phone over to this SIP phone, how many channels do I have open? I still have 2 channels. Okay? And this is very important at a technical level because Asterisk is what you call a back-to-back user agent. Okay? So if you're familiar with SIP, if you're not, that's cool. We'll talk a little bit more about SIP in our training classes and Asterisk Essentials Online. We talk about SIP. But at a real basic level, if you're familiar with working with SIP, typically, SIP calls are routed by what you call a SIP proxy, and this is because you have what are called smart endpoints. So they've graduated college. They're very smart endpoints. And the smart endpoints, they know how to talk to each other. They know how to pass media directly to each other. It's basically like a mini computer in there that we call the smart endpoints. And so in order to route a call between 2 SIP telephones designed in the protocol spec, it doesn't really need to connect to something in the middle. It just needs a proxy to route the call. So when you have a SIP proxy, and a call comes in from one SIP phone and it goes through the proxy that gets routed to the other SIP phone, that is one SIP call, right? There's going to be one unique ID on that call. Of course, I see David Duffett just popped his head in to see my terrible drawing of England. You've got one SIP call, one unique ID going across there, and it's just routing through a proxy. Asterisk, on the other hand, is what you call a back-to-back user agent, okay? Asterisk is actually the destination of a call. So that means when you send the call, it doesn't actually terminate on the other phone. You've got 2 channels, 2 unique SIP IDs, okay? So this is going to be a unique ID, and this is going to be a unique ID. That's kind of sloppy writing. But the idea there is you've got those 2 SIP channels, and Asterisk is bridging those channels together. This is both an advantage and a hindrance to us, right? So in some senses, Asterisk is a back-to-back user agent, so it stays in the signaling stream, but it's really more of an advantage. So for example, we can keep Asterisk in the media stream. Let's say we want to record audio, right? This is how we record audio. Rather than passing the media directly between these 2 endpoints, we're running our media through Asterisk. And by media, I mean like the voice or the video, right? And in particular voice, when we're talking about telephony. We're running our voice media through the Asterisk server. It's able to record that. It's able to listen to it. So let's say I want to have DTMF feature codes. I can punch in numbers, and Asterisk can listen to those numbers and say, oh, when you hit *2, I know you want to do a transfer. Or I know you want to record the call, or there's all kinds of functionality because Asterisk is in the media stream and it can listen to those things going on. Of course, Asterisk does allow you to pass media directly between the endpoints, but the signaling still flows between Asterisk. It still has 2 unique IDs because it's a back-to-back user agent. Okay, so that's kind of a little note on channels there. Interfaces into Asterisk. Okay. Like I talked about, we're going to have .conf configuration files. So Asterisk is configured by text-based files. These text-based files have a really simple syntax. I'll show in a slide here in a moment. There's a few other interfaces. The command line interface, okay? And I've already showed you guys the command line interface earlier. The command line interface allows you to administer Asterisk by issuing commands. You can load and reload modules. You can even add dial plan commands. There's a lot of administration you can do at the CLI, and that's the administrative interface. A lot of guys that maybe you've come from a GUI background, maybe you've done a lot of system administration, and typically I tend to see two guys coming in, two different types of guys that come in. I mean, there's several different types. You got like programming guys and Linux guys, but for those who are new to the project, you typically come from like a sysadmin background or maybe like a networking background. And the networking guys, they're all about the CLI. When we're logging into the switches and routers, we're all about the CLI, so that's kind of normal to us. For the GUI guys, the CLI can maybe seem a little bit intimidating, but I would give you the encouragement today that it's really pretty simple. The CLI is a very powerful tool, and even if you've never used a CLI before, I would encourage you to learn a little bit about the Asterisk CLI because there's a lot of information you can use there. I'm going to be using it all day long and showing you some tips and tricks on the CLI. And it's not as hard as it looks. So there's really a lot of power that you can use there. Additionally, we have AGI and AMI. These are really cool. So the Asterisk Gateway interface is a programmatic interface. This is going to allow us to run a script or a program in almost any programming language we want and interface it into Asterisk. Okay? So this allows me to do a lot of things. It allows me to, first of all, to scale. I said there's other ways besides building a custom C module. That's a pretty hefty thing. You would do that for like a new channel, but you don't want to do that every time you've got some new feature. If you want to interface with your system, we have the Asterisk Gateway interface. So let's say I'm a PHP developer or even a JavaScript developer, and I'm using Node.js. In fact, there's a talk here at AsteriskCon about Node.js. You could be using Python. You could be using C. You could be using PHP, whatever programming language you know, and you build your script in your programming language. And then via the Asterisk Gateway interface, that gives you, when the call comes in, we can route control of that call out to the AGI, out to the Asterisk Gateway interface. And then our script over here that I wrote in PHP, or my script over here that I wrote in Python, is actually now controlling the call. So this allows me to do really cool things. This allows me to integrate with other solutions. There's really cool things there I can do with that programmatic interface. Additionally, we have the Asterisk Manager interface. The AMI is a method that I can likewise have an external script control Asterisk, but now I can do it over, say, like a TCP socket. And so AMI is really more for like live control. So AMI gives me a TCP socket. I've got essentially like an IP address and a port I can plug into Asterisk, and I can send communication back and forth. This is used a lot of times for, let's say, a GUI interface. So with SwitchVox, there's a SwitchVox GUI interface, and I can log into my SwitchVox user interface and bring up my call panel. In SwitchVox, we call it the switchboard. And I have my switchboard open here on my computer. When a call comes into my phone, my switchboard pops up a notification. It says, hey, you've got an incoming call. And if it's somebody else within my company, it shows me their profile picture, and I've got all this kind of data. Well, how did it get that data? Well, that GUI is of course, running off of a web server. It's a web page that's being served to me, but it's talking to Asterisk via the AMI. So it's sharing data. So when Asterisk gets a call for my phone, it shoots out a little AMI message to the GUI, and it says, hey, do a screen pop. And when I answer the call, let's say I want to transfer somebody, I can click on my GUI, and I can drag that call over to my phone book. You can do this in SwitchVox. And it sends an AMI message back to Asterisk and says, hey, go transfer this call. And so if you're building a custom GUI, you can likewise do the same thing. You can use the manager interface to communicate. This is used a lot for operator panels. And like I said, more real-time communication. If you want to integrate with an external script, you can do so via AGI. I'll give a moderate plug for my other talk. So I'm doing a talk tomorrow, and I call it Dial Plan Scripting for Non-Programmers. So if you're a non-programmer and you want to dig a little bit even deeper than we go today into dial plan scripting, I'm going to be doing a talk tomorrow. And there's a lot of content that I hope to get through. Today I got like 8 hours. They're like, oh, here, you had 8 hours. Tomorrow I get a half hour. So I don't know if I'll be able to cram all the content in a half hour, but tomorrow I'll be talking about the AGI. If I have time, I'll actually show you guys an AGI script. Today we'll mostly be dealing with the CLI and our .conf files. So here is the .conf configuration file. It lives in etc asterisk, and so we call this the path, or really the directory. Path is actually something different. Path is where we're going to execute commands from in Linux. But this would be the directory. What directory is it in? And so if you come from the Windows world, this would be like your folders, right? What folder is the file in? So it's in the etc folder. We call that etc, etc, and asterisk. So in etc asterisk, and then we're going to have all of these files like filename.conf. So for example, to configure SIP, we have sip.conf. To configure our dial plan scripting, we have extensions.conf. To configure voicemail, we have voicemail.conf. Just by show of hands, how many people in here have actually edited a text-based .conf file before? Okay, quite a bit. How many people have used like a GUI interface, let's say FreePBX or SwitchVox, other type GUI interface? Okay, cool. So you guys are pretty familiar. For those that are new, basically this is like any style syntax. So if you've done like any configuration in the Windows world, this is kind of similar syntax. So in order to have a section heading, we're going to have square brackets. So square brackets kind of tell me, hey, I've got some kind of section that I've got here. And then we're going to be configuring with key value pairs. Okay, I'm going to have a key and I'm going to have a value. So for example, I might have caller ID equals, Billy Chia 6099 or whatever my caller ID is. I might have options set to yes or no, or I might have a type setting, type equals friend or type equals peer. And you have those key value pairs. That's how a lot of configuration is done. If I want to put comments into my file, the way Asterisk reads these files is it reads them from top down, one line at a time. Okay? So it takes the text-based file, and it starts at the top, and it starts to parse the file, going from the top down. What will happen is if it reaches a semicolon, it considers that a comment. It says, I'll skip this line. I won't actually parse this line. This is helpful for us in two ways. The first is, obviously, if we want to comment our code, or comment our configuration. If I put in a configuration and I just wanted to make a note to myself about why I've got particular codecs on a certain phone or why I've done a particular bit of dial plan scripting, I can put a comment in there, and that is wonderful. That means when I come back to that configuration a year later and I'm like, why did I do this? I left myself a nice comment. Or it's a favor to the next guy who has to come and work with your configurations if it's well commented. The other advantage that we have with comments is it allows us to test configurations. So because a line that is commented out does not get parsed, I can have two different configurations. And I say, let's say I want to run this one. I can have this one uncommented, and I can put a semicolon in front of all the lines here of the commented configuration, and that configuration won't be parsed. When I reload in, it basically ignores those comments. So in Asterisk, we use a semicolon. If you are familiar with Linux, you know that most Linux.conf files actually use the hash or pound or the number sign as their comment operator. Would anybody think why, when all the other Linux stuff, or most of them, use the pound sign or the hash sign, why would we go with semicolon? Yeah, it's a pound character on the phone, right? So we want to be able to use that pound character to mean something else. We want it to mean DTMF tone. So as a result, in Asterisk, we use a semicolon comment operator. And that's it. We've kind of reached the end of our architecture. We've got a few moments here. Maybe I'll try to field some live questions and see what we've got. Do we have any questions on the introduction to Asterisk, our architecture, things that we've covered so far? Okay. It's probably early in the morning. We need to get some coffee. So let me take a look at my schedule here on how we're coming along. So what we'll do is we'll take a little bit of a break. I would love to meet some of you guys. Like I said, hear your story. What we'll do is we'll start back up in the room right about 10 o'clock.